Hello friends, this is Durga again from IT Varsity, a one-stop shop to learn all the technologies. Some of you guys might be familiar, whoever is joining in YouTube Live. I have started this Scala and Spark workshop. It is supposed to be done in 3 consecutive days, couple of weeks back. But because of some family emergency, I have to stop in between. And last week I have covered a couple of sessions, and today we will conclude with a couple of more sessions. Okay, so that being said, let me validate that you guys can see me and also you can listen to me. Yes, you guys can see me and you guys can listen to me. So let me get started. Already I have set up the WebEx session. If any of you want to be part of WebEx, and if you have already made the 54.95 plan, payment for the 54.95 plan, you can ping me and I will add you to the WebEx session in case if you want to interact with me directly. So that being said, let us get started. Let us recap where we are before we proceed further. I will also give the link to the playlist for the workshop for your reference in future. So this is the link for the playlist for your reference. I'll be pasting in the chat also. Okay, and if you go to the playlist, in the first 2 sessions, I primarily cover Scala and also to set up the environment. So we set up IntelliJ IDEA, and then with Scala plugin, and then we actually started exploring the basics of Scala, which are highly relevant for Spark. And then as part of session 3 and session 4 as well as session 5, last 3 sessions, we actually covered a lot of Spark-based APIs with respect to transformations and actions. And the list of, I will rename the titles also based upon the content covered, and also I will add a few details on the description, and also I will create a blog on this workshop later so that you can use it for reference. Anyway, for now, I will go to the documentation and explain what all are covered. So this is the official documentation of Spark. You always should start with official documentation. If you could not figure out certain things in official documentation, then you can explore Google and you can get your answers. So as part of this, we have seen map, filter, flat map. And those who are on WebEx, please confirm that you guys can see the screen, and also you can listen to me before we proceed. Okay, that's good. So we have covered map, filter, flat map. And then we also covered reduce by key, aggregate by key. We have covered join. Okay, so using these things, we have seen how to join multiple data sets and aggregate those things. Now let us explore next API, which is very, very important. That is group by key. And before actually getting into group by key, let us get the relevance of it in some business terms. So typically, when it comes to the requirements, when the business requirements are translated into technical specification, when it comes to processing the data, we always hear about data cleansing, data standardization, aggregations. Those are the things which we typically hear as part of the business requirement. On top of these things, one more important aspect is sorting and ranking. Okay, so along with group by key, we will also cover all the details required for sorting and ranking as part of today's workshop. Okay, so today we will begin with sorting and ranking, and we will get into data frames. we'll get into data frames, and then we'll conclude with the afternoon session where we will continue on data frames, and we will also look into Spark streaming. Okay. So when it comes to grouping, ranking and sorting, there are two types of requirements. One is global ranking and sorting. Other one is sorting uh, uh, within a group. I will give some real world scenarios. For example, you have a major retail store and which have franchises across the country. And if you want to see what is the best performing store or what are the top 5 performing stores across all the stores, first what you have to do, you have to aggregate the data to get the revenue. Revenue is one of the KPI, or key performance indicator, to quantify the performance of a store. Let's take the example of revenue or profitability. First, we need to compute the profitability or revenue of by each store. So first, we need to aggregate per store, and then we have to, if you want to get top 5 stores, you just have to sort in descending order by revenue, and then you will give the rank from 1 to 5. Otherwise, you can also do just sorting to get the details of stores sorted in a particular order by revenue or profitability. These scenarios are global in nature. Okay, so if you have to do global sorting, one of the API that is available is sort by key. Okay, which will get you get the data in sorting order by key. And if you sort by key covers global sorting based on a key or a combination of attributes. Okay, and then if you want to get ranking, we have to use take of n after sort by key, so that we get only top 5 or top 10 records using take. We can achieve that. On top of this, there is also a API which is not documented here, called top, which is nothing but sort by key and then take off sort by key in descending order, and then take as many number of records that are requested as part of top command. So you have sort by key and to sort the data, sort by key and take to rank the data, or you can use top in place of combination of sort by key and take. On top of this, there is another API called take ordered. So what I'm trying to say is, for global sorting or ranking, you have to use these APIs: sort by key, take, top, and take ordered. This will take care of global sorting. And then if you have to get ranking or sorting by key, okay, this sort by key might not be very flexible, especially when it comes to ranking. Sort by key, take, all these combinations are not very flexible. We are trying to sort the data by a key, and for such kind of scenarios, there is no other option than using group by key. Okay, so group by key is to sort the data within a key, and sort by key is for the global sorting. And once I demonstrate the global sorting, I will explain again about the relevance of by key sorting as well as ranking, and then we will get into scenarios where we can use group by key. So again, for these okay, here SNDS is the project which I'm using to demonstrate for the Scala and Spark workshop. Okay, I will try to check in into the GitHub also later, not into the gist but the GitHub, so that you have the code for our reference, and I will send the notification to everyone to fetch this code. Okay. So make sure you are in the right location. You have to be in the base directory of your project, which is SNDS in this case. So this is the base directory, and if you run ls-lpr, you should see this build.sbt and source directory in that. And then you can run sbt console, which will launch Scala with all the dependencies resolved. So you will have access to all our Spark APIs, because in build.sbt, we have defined, okay, this is not the project, this is different project. Let me open our project. Okay, if you look into the, let me close all these things, they are not required. And these are the packages which are defined as dependencies as part of build.sbt. So these packages will be available. I'm just trying to recollect what we have covered earlier so that you get into the context. That's the importance of SBT console. It will launch Scala with the dependencies resolved. So we can start using our Spark APIs. Now, first what we have to do, we have to import arg.apache .spark .spark context or configuration. Once imported, we have to create the configuration object like this. New Spark const set app name global sorting and ranking, and then set master local, because we are running locally. I'm trying to launch it using local, and then val sc equal to new Spark context const. So now you can run the sc.text file and try to read the data from a dataset called products. So I will be using products to demonstrate this. So for that reason, I am actually creating variable with name products sc.text file, users, IT university, research. I have covered towards the end of the, I have covered this towards the end of the last session also. I'm trying to just to recollect a little bit quickly, and then we'll get into group by key. Okay, data, and then retail underscore DB products. And we have one bad record in this. So I'm trying to use filter and filter out that bad record. X85 is the record. Okay. So let me just give me a moment. There are few, I'm getting some background noise. Okay. Mute on entry and then disable entry and exit tone. Okay. Now, if you do products.count, you will get 1344 records. Total, it was 1345 because we filtered out one record, and now we got 1344. And then if you say products.take of 10, you will get them as an array. Okay, so the data looks good. Now what I'm trying to do is I'm trying to sort the data. So what let us define the sorting criteria. Sorting criteria is price. So I want to see um, all the products in descending order by price. Okay. So to use sort by key, if you go to the definition of this definition of this API, when called on a dataset of KV, which means that we need to pass the data in the form of KV pair, key value pair or paired RDD. Okay, so for that purpose, first we need to identify the key on which we want to sort the data. In this case, I want to sort the data by price. And then value, you can fetch whatever fields that you want from this data set for each record, and you can pass it as a value. In this case, I want to fetch everything, and I just want to display the data in descending order by price. So to convert into the tuple of price comma record, I have to use map here. Okay, and then rec dot split comma, and this is 0, this is 1, this is 2, and there is empty field 3, and this is 4. So I have to say 4, and we have to typecast to the correct data type, and this should be part of the tuple. Okay, and then I want to uh, pass the entire record as the value. Okay, now it will actually create RDD of type float and string. The first element of the tuple will be price for each record, and value will be the record itself. And then we can apply sort by key. If you want to get the data in descending order, you just have to say false here. If you just do not pass anything, it will by default take true. Otherwise, it will take false. And then you can say take off 10 dot for each println. Okay. So now you see you got the data in descending order by price. Okay, so sort by key and take the combination will actually get the ranking. If you just want to sort by key and if you want to display all the records, you just have to use collect here. And then it will fetch all the data. It will take care of the global sorting. Instead of sort by key, you can also use top. Okay, top of n. So what it will do is it will sort the data in descending order by the key, and then it will get the values. Okay, and if you hit enter now, you can see the data in descending order by price. Okay, if you just want to get the record, but not, means if you want to display in the in appropriate manner, you can use for each println. And now you can see because top includes sort by key and take. Take actually convert the RDD into an array. So that's why top actually returned array. And if you want to display, you can apply for each on it and you can actually display. And if you just want this thing without the price while displaying, you have to again use map here. Now you cannot actually do map here. After applying the top, you have to do the map. Okay, and then here you are only looking for the second element of the tuple. So you can say underscore dot underscore 2, or like you can give name and variable name dot underscore 2 also will work. And so here either you have to use map to create the key value pair and then sort by key and then take, or you have to use map and top to get the ranking done. And there is one more way of taking care of ranking, which is take ordered. Okay, so in case of take ordered, you don't need to do map, sort by key, and then take or map and top. You can directly say take ordered and you can define the logic. So take ordered takes the first parameter of the take ordered will be number of records you want to see, and the second parameter will be the ordering logic. Okay, so here you can say on the products itself, take ordered. When you develop using Scala based Scala programming language, it takes two parameters. The first parameter will in two different circular brackets. The first circular bracket you have to pass the number of records you want to see. In the second bracket you have to apply the logic. Okay, so you can say ordering of float. This is because we are trying to sort by float. Okay, and then you can say on. You have to again, this ordering is Scala type. It's a Scala API. Okay, and here we have to give the logic about how you want to sort the data. Okay, again you can say like this, minus k dot split, comma 4 to float. Okay, so it will sort the data in descending order. What is it? Yeah, I gave k instead of rect. And, yeah. Let me check the syntax. Yeah, syntax is not correct, that I understood, but let me recollect the syntax by going through my GitHub repository. So if you are using take ordered, make sure you practice a lot, because even after demonstrating so many times, I could not remember the take ordered syntax. I always fail to do so. Okay, so that is actually we don't need to say this. We just have to pass the define the ordering function. Okay, now it works. Sorry, okay. So that is the usage of take order. It is same as using map, sort by key, and then take, or map and top. You define the map logic as part of take ordered itself, and it will internally use it. And now let us compare all the executions and see which. Okay, I'm running this on the local machine. So let me run the same thing on the lab, and let us see the difference with respect to the DAG, how the DAG is working. That will give some idea about the performance. Okay, so I am launching Spark Shell here. After logging into the gateway node, I'm running in the add mode on spark.ui.port, and make sure you understand this conf. It can come handy in many ways. That's why I am always using this. Okay, not only for the UI port, but in terms of others also, like number of executors. If you have to process too much of data as part of the certification, and if you just run with the default number of executors, it will only use 2. Okay, which will waste your time. Rather, if you launch Spark Shell with the number of executors with a lot more number, first you need to understand the cluster capacity, and based upon that, you can give the number of executors. One way to understand the cluster capacity is you will be given access to Cloudera Manager. Using that, you can do that. Even if you don't want to launch the Cloudera Manager, let me see if there is other way. So I'm connecting again in another session. Okay, so here cd etc spark conf. You will have access to this, read-only access to this. And here you can go to spark env.sh. Yeah, here you can see here Spark executor instances is 2, Spark executor cores is 1, Spark executor memory is 1 GB. Okay, so you can override these things. To override Spark executor instances, you have to configure conf is to override the any property. Okay, um, in this case, I am trying to override UI port, but there are some properties where you already have helper properties without where you don't need to remember the actual property name, and that one you can actually get by running spark shell -- help. Okay, so if you want to override any property which is available directly like this number of executors, you can say -- num executors. If you don't see that here, but if you know the property name, try to use -- conf and you can override the property name. So let me copy this here and then non-executors. Let me say 4 just to demonstrate and hit enter. Now I am actually going to resource manager web interface. I disabled the display of logs here, and that's why we are not getting the URL for the job. Hence, we have to go to the resource manager interface, and then you have to access the appropriate job here. Okay, and this is the one. I'm clicking on this. And if you want to get the details about the properties, whether they're overridden or not, you can click on environment, and you can see here. Okay, number of execute instances is the actual property name. Either you can say -- conf spark execute instances and set to 4, or you can directly say -- num executors. So if you don't know the properties, you can go to this environment, and sometimes you can get some insights about what could be the property name, and you can pass it as part of -- conf. Okay, so now it is started. Let me read the data. Val products equal to sc.text file public. This is the HDFS location where I have golden copy of the data, public retail _db products, and then I have to apply the filter logic. Let me copy paste from here. Okay. Now let me run all the three. The first one is using map and then sort by key and take. So this is the first one. Okay, you can see the data. And the second one is using top. You can see the results. And third one is using take order. Okay, all three are three different approaches. Now we are trying to understand if there will be any performance difference by going through the jobs that are executed with respect to each of them. Okay, so if you look at this one, so the first job the first invocation actually created two jobs, one for sort by key and the other one to perform the take. Okay. So if you see, it just created one job till sort by key, and then it passes that as input to take to get the first 5 or 10 records which we are trying to display. So it is a two job process. Whereas when we do top, when we use top, it did not translate into two jobs. It actually ran as only one job, and we got the results. Okay, and then the third one is take ordered. It also ran with one job, one stage, and fewer transformations. So out of these three, take ordered is better, but little bit complicated. Okay, sort by key is actually resolving to two jobs, whereas the top and take ordered is resolving into only one job. But uh, uh, to use top, first you need to use map function. So within the stage, first it has to apply the map transformation, output has to be generated, and that output has to be processed to get the top records, right? So even though it is running only in one stage with respect to top, still take ordered beat it, because the entire map and sorting and taking the records is implemented as part of one thing, but developing is a little bit complicated because you need to understand how to use ordering effectively. Okay, but sometimes you might not have the flexibility that will be given to you by sort by key. In some cases, you need to use sort by key. Okay, that being said, again, sort by key is primarily to sort the data, and take ordered and top are primarily to rank the data. So in general, if the use case is just to sort the data globally, use sort by key. If you want to if you want to rank the data, use top and take order. Now the second use case in the similar lines is, right now we are actually sorting only by price. Now if you want to sort by category and then price, within each product category, I want to get the prices in descending order. In that case, you can use sort by key, make your key as composite. It should have both product category ID as well as price. Okay, and then you will get the results. But if you want to get the ranking within each group, none of these things will work. Sort by key does not work. Sort by key is primarily to sort the data. And if you apply take on sort by key, it will take the entire input of the entire output of the sort by key as input to take, and it will only get first 5 or first 10 records. Okay, so you cannot get by key ranking done with sort by key and then using take. Similarly is the case with the top as well as take ordered. You will not be able to get by key ranking. For these scenarios, you can use the very powerful API called group by key. It's a highly generic. You can do whatever you want. Wherever you have to perform certain tasks on a group, on a key, based on a key. If you want to get all the values based on the key and do some transformation on that, you can use group by key. But when it comes to aggregations, because as group by key does not use combiner, we prefer aggregate by key or reduce by key. But for ranking purpose, we have to use group by key, and we have to implement our we have to leverage our Scala skills to do further processing. It can be ranking, it can be any other complex transformation on the values grouped by a particular key value. Okay. No, there is nothing like local sorting, local ranking, by key sorting or by key ranking. Okay, you can get by key sorting also using sort by key, but for ranking you have to use group by key only. Okay, so now let us define the problem statement. In this case, I want to display top 5 products based on price. Okay, that is my requirement. So someone is not on mute. Let me. Based on price. Okay, that is my requirement. Okay, I think it is good now. Okay, let me see. Already. Okay. Okay, so if I have to get ranking based on group, based on product category ID. So let us understand data real quick here. So I'm just saying product dot collect, and then for each println. I displayed the entire data, and let us understand the column, each column. So this is product ID, which is the unique key for this data set. This is the product category ID. Okay, product category ID will give the category level details, means the category ID, and there is a table called categories, which will give us the details for each category, the name and other things. And this one is product name. I do not remember what this empty field is. For most of the records, this field is empty. And then we have the product price. So this one is product price. And this one is product image. It's a URL for the image. Okay. So it's 1, 2, 3, 4, 5, 6 field table. So in this, I want to see the ranking of products within each category, and I will pass the rank as parameter. So if I give 3, I should get top 3 products within each category. If I give 5, I should get top 5 products with each category based on the price. Okay, so that is my requirement. Now, if I have to get within each product category ID, I need to group the data with product category ID. Now let me run products.count, which will give the number of products in our dataset, which is 1344. Let me see. Some guys made the payment, and they might be looking for the WebEx session. Okay, no one have asked it. Okay, anyway, so products are 13. There are 1,344 products in this dataset, and now what I'm trying to do is products group by category. Okay, so for that, what we have to do, first we have to apply group by key. Again, it has to be key value pair. You have to get the key, means you have to pass each record and get the key, which is product category ID in this case, and you can have whatever you want as value. So I'm using the same logic here. Rec.split, comma as the delimiter, and then fourth field is the product price, and we have to typecast to float, and then rec, which will give the record for further transformation. And then if I say group by key, it will be grouped. Sorry, here I have to use product category ID is the second element. So I have to say rec.split of 1.2 int. Okay, so we are actually splitting this by commas delimiter, which will generate an array, and then I'm fetching this one and I'm casting it to integer. Okay, and then I have to specify group by key here. Hit enter. Now you see the RDD is of type means this products group by category is nothing but of the type of products group by category is RDD, and each element in RDD is a tuple the first element of the tuple is of type integer, and the second element of tuple is of type iterable, which is nothing but array or collection. Okay, so now if you want to preview the data, you can say products group by category dot take of one dot for each println. Okay, now you see you got one record. Compact buffer is special way of representing your collection. That's why it is showing it as compact buffer, and it has n number of records in this. And this is the product category ID. Now, if I say products group by category dot count, products have 1344 records, whereas products group by category have only 55 records. But each record value is a collection. It's not individual tuple. You can also say products once you group by particular key. Immediately, we have to either use map or flat map on this. Okay, when to use map? If for each one record, if you want to get another record as output, you use map function after group by key. For each input record, if you want to flatten the elements in the array, you have to use flat map. So, for example, if I just want to display all these records in descending order by price, whatever is part of the value, in that case, we have to use flat map. If I just want to get the size of each collection when after grouping by key, in that scenario, I can use map. So I will do that. Do the both. First, I will try to use map, and let us get the size of each one and print it. Okay. So here rec dot underscore one will be the product category ID, and rec dot underscore two dot size will give us the size of the collection, and then collect, and then for each println. That's what I'm saying. Rec dot underscore two dot size. It will give the size of the collection. So you have to be familiar with the APIs relevant to Scala collections. Okay. So now you can see for each product category the size of the collection. Okay. So if you want to if you want to test these things out, what you can do is you can actually say, so array or list are iterables. Okay. So you can create a list like this. If you are interested, these records are nothing but collection. Okay, so you can actually copy this output, but only thing is each record has to be enclosed in double quote. Okay, so this is one record. This is another record. This is another record. Like that, you can actually fetch whatever number you want, copy this thing, and then you can say val L equal to list of, and hit enter. Now L is of type list, which have elements of type string. And if you do L dot tab, you will see all these APIs. Most of these APIs will work on any collection. Okay. Now to get the size of the array, you just use L dot size or L dot length. Both will work. Okay. If the list contains integers, you can do L dot sum or min or max to get min or max or sum. Or you can use L dot map to do the transformations, fold or reduce to do the aggregations. There is a group by also, where you can actually perform by key transformations using list also. But keep in mind that list is single threaded and it's Scala based data structure, and whatever we are talking in Spark is RDD, which is a distributed data structure. So unless and until it is inevitable to use Scala based functions, you should always prefer to use Spark APIs. But once you group by a key, the values are Scala type of iterable, Scala type of collection. Hence, you have to use Scala APIs only on that data to perform whatever transformation you want to perform. If it is Python, you have to use Python. If it is Java, you have to use Java. Use your Java skills. Okay. So now map is for each record in that will be passed as input after group by key. If you just want to get one record as output, you use map. In the other scenario where you want to sort the data in descending order by category ID, and if you want to display, instead of using map, you have to use flat map. So here you can delete all these things. And I am using flat map. And I don't want to get the key. So I'm instead of displaying it as tuple, I just want to display the individual record from the value, but sorted in descending order. So what I can do is rec dot here. Yeah, started already. Do you need this room?
We have a all partners meeting.
Okay, okay.
Don't mind, can use that.
Yeah, I will go to the first floor. Okay, okay. So just give me a moment. I will reconnect. If it gets disconnected, I will get reconnected in 5 minutes. Okay, less than 5 minutes.
Sorry, మీరు సాటర్డే లేదని కాబట్టి పైన పెట్టుకున్నాను యాక్చువల్లీ.
ఓకే ఓకే
అదర్వైజ్ అక్కడ పెట్టుకునేవాళ్ళు.
It is a 3-day workshop. Okay. Why stick out on the postpone? That's fine. So just give me a moment, guys.
Thanks.
Sure. Just give me a minute, okay? We are almost there. Sorry for the noise. I hope you guys can see my screen. In WebEx, YouTube, let me share my screen again. It got dropped. And right now it is running on Wi-Fi. In case if you see any issues, let me know immediately so that I can switch to the cable. Okay. So please confirm both on YouTube as well as on WebEx that you guys can see my screen so that I can proceed. Okay, thank you, Vicky. And sorry for the distraction. So here I am connecting to the lab again. And let me use that command which I have used earlier to connect. Just give me a moment. Okay, so it is started. It is starting. Then we will see. Okay. So first, let me run these commands. I'm trying to read the data and apply the filter. And then I ran the group by key. And now I'm trying to explain how to use flat map on the group data. So here you can say products group by category dot flat map. Okay, and rec is input and rec is of type tuple, and I don't want to use key anymore. I just within each key I just want to sort the data. So what I can do, I can say rec dot underscore 2. So rec dot underscore 2 is of type array, and each element in the array is of type string. Okay, so on that I want to sort the data in descending order by price. So first I am converting that into the list. Okay, once converted into the list, I can apply the map function because I need to sorry, not map. I can directly say let me actually use this one itself. Let me use the typical Scala collection. First, let us come up with the logic on top of it, and then we will use it as part of the flat map. Now I'm copying this tree and creating a collection. Okay. And now if you say L dot for each println, you will get the each element in the array has separate record like this. Now we are trying to sort the data. So this is already list. So L dot, there is a API sort by, sort with, or sorted. Okay. So in this case, I want to sort based upon certain logic. So we have to use the API called sort by. Okay. I don't know the scenarios where sort with and sorted are used, but you can explore those things. But for this purpose, we have to use sort by because we are trying to sort by the price. Okay, sort by and k implies a dot split, comma 4 to float, and we want to sort in descending order, so we have to negate this. So here we are just saying, based on this logic, sort the data. Okay, we are not actually developing the complete sorting logic. We are saying sorting logic is already there as part of the sort by function. We are only saying use this logic to sort the data. So it's similar to filter. Filter, if the expression returns true or false, it will include the record, otherwise it will discard the record, but the record itself will not be transformed. In this case also, each record will not be transformed, but it is using this logic to sort the data based upon this logic within our collection, which is, and each element of collection is of type string. Okay, and if you run this command, now you can see first you got 169.99, second you got 59.99, and third you got 59.99. And if you remove that minus, it will be in ascending order by the price. Okay, now you got 59 first and then 169.99. So now we can actually use this as part of our flat map logic. Okay, so rec dot underscore 2 dot to list and L will be same. L is of type list and rec dot underscore 2 dot to list is of type list, and each element in the list is of type string. And then use sort by. Actually, I can copy paste this logic. Okay, and sort by returns the list. So flat map, what it will do, it will take the list and it will flatten it out. And then we can say collect dot for each println and hit enter. Now you see the data is sorted within each product category ID. So in this case, 5 is one product category, and data is sorted in ascending order because our sort by logic does not have the minus. Okay. Now data will be sorted in descending order by price. Okay. If I use map instead of flat map, what will happen? Will it fail or will it work? What is your guess? Instead of flat map, I'm just using it as map. Products category group by products group by category is RDD of type float and sorry, not of type integer and iterable. Even after applying the map function, you will get the same thing. The output will be of type RDD, and each element in RDD is of type tuple. First element will be product category ID, which is integer. Second element will be collection, which is iterable. But the collection will be sorted in descending order by whatever logic we have mentioned. So map will not flatten out the data. It will just return it as array. Okay, you can see it here. Now, if you look at one thing, so this is the beginning for 43. This is the collection for 43. Okay, 4300 is somewhere in the middle itself. Last one is 5. So let us identify the boundary. Yeah, here. Okay, so if you do the count on flat map, after flat map, if you do the count, you will get 1344 records. If you do the count on map, you will get only 55 records because each record is of type tuple. The first element is product category ID and second element is collection. Okay, so sorry, after applying the map function, we are only getting the collection. We are discarding the key. Okay, so that's why we got only the collection. We did not get the key. Now, using this group by key, let us improvise the requirement. What is our requirement? We need to pass. We'll pass an argument saying get me top 5 records or top 10 records, and we have to display those many records. So to demonstrate that, now I will be using uh, IntelliJ, okay, and I will be developing the program. So here I am saying I am creating object, and the name will be uh, open products by price. That is the name. Okay, and as we have been doing, we should externalize the parameters such as execution mode, okay, and we should pass the input path and output path as argument, okay. So the input path will be the result set for the products, output path will be wherever we want to store. So I will just copy these things because the logic does not change a lot till here. So I'm just trying to copy from here to here. Def name args array of string, and then paste these things, okay. And then we want to get products c dot text file input path. Till because we are only dealing with one data set, we will pass the entire path, the directory where we have the product data as the input path, and then I have to apply the map function, sorry, filter function, to discard that invalid record, okay. X dot split. Ideally, we should not do like this directly. We have to handle it more gracefully, but for now, we are just comparing like this, not equal to 685. Okay, and then val products group by category equal to products dot group by key. I have to apply map x dot split, comma, 1 2 it. Okay, now we have grouped the data by category. Now val top n products equal to products group by category dot flat map. Here I need to get the logic implemented. Okay, so here we have to write multiple lines of code, or we can also create a function and we can invoke the function. I will write directly here. Okay, so first thing what we have to do, we have to convert that into list so that we can use whatever logic we need to. And then as mentioned earlier, we can use the sort by also, okay, like this. Okay, So sort by will actually sort the data in descending order. And then once you sort the data, what you can do, you can say take, and you can actually pass the argument. So in this case, the fourth argument, let's say, will be the number of records you want to get as part of top n, whether it is top 3, top 4, etc. So we have here we have to say args of 3. So the program will take 3 parameters. Okay, it is okay. Correct only. It is confirmed. So rec dot underscore 2 dot to list dot sort by. Let me try again. Dot take. Okay, I know. It has to be args of 3 dot int. Okay, because it takes only integer as parameter, but argument is of type string. So we have to typecast it to int. Then it will get top n products. That's it. It's as simple as that. So here what we are trying to do, we are actually using the list APIs to sort the data and then take as many as we want. Probably it might also have the top. So let me validate that. No, there is no top here. It have only take. So we have to use take only. Okay, and I think using take while we can even implement a little bit of complicated logic. But anyway, we will not discuss further about it. So here, after sorting the data, we will just uh, we will just save it into a file. So here I'm saying top n products dot save as text file, and as I have been mentioning to you earlier, I just want to save uh, the record, whatever was there. So in this case, we don't need to do any transformation because the rec have in this case whatever we are passing to flat maps, uh, whatever we are processing as part of flat map is rec dot underscore 2, which is nothing but of type list, and each element is just the plain record. So we just want to write like this as is. So we don't need to worry too much about applying any further transformation while writing into the file system. We just give the output path. And then to run this, you can go to run and edit configurations. Okay, here we are trying to create new ones. So click on plus application. Pick the class, in this case top and products by price. Let us give the name also. And the first argument is whether we want to run it in dev mode or product mode. Let us pass it as dev, and then users IT varsity idea projects research data retail underscore db products, and then users IT varsity research data top n products. Okay, apply. Make sure you use class path of module to your project, and then click on OK. And then you can right click and then run top n products by price. Now, because we are only sorting data on the values by a key, your data will not be globally sorted. If you look at the data which is saved into the file, the data will not be sorted by product category ID. It is not required. But within each product category, data will be sorted. It will be grouped by product category ID, and then data will be sorted by price within those values of each product category ID. So there is some issue. Okay, I need to pass one more argument. That's why it failed. The last one has to be how many you want to pass. Okay, we can handle it more gracefully. Sometimes we use default number of default value if argument is not passed. If you want to include that logic, you can include that also. Now it is done, and if you go here, cd you can get the data here, and if you look at the data, you got 3 records for each product group, product category ID, but globally data is not sorted on the category ID, which is not required in this case. Okay, so that being said, now let us make it a little bit more complicated. If you look at 34, you see there are 2 prices with 169.99 and 1 price with 149.99. Instead of just getting top products by price, if you say I want to get top n priced products, so I want to get all, if I pass 3 as parameter, I want to get all top 3 prices, and all the products which fall in the top 3 prices list, I want to get that. It is called as dense ranking in traditional terms. Okay, so if you want to simulate the dense ranking as get top n priced products from this list for each category, it will make a little bit more complicated. So the design will be like this. First, we have to go to the result, the collection, and get top n priced top n product prices. So if we pass 3, we have to get 3 distinct product prices. If we pass 5, we have to get top 5 distinct product prices, and then we have to validate the actual records by doing a lookup into those top n prices. And if the product price of each record falls in that list, we have to return those results. So this will make our logic a little bit complicated. So let us improvise to get that one. Okay, so I will develop another program for this. I will say top n priced products rather than top n products by price. Okay, so I am actually saying new Scala class object top n priced products. And if you go to this results, if you look at, I think 59 or something, 59, you see all hundreds, and there are a number of records with this price itself within 59. Okay, so if there are 10 records which falls in the category of top 3 priced products, we have to get all those 10 records. If there are 15, we have to get all 15. Okay, so we are trying to develop that one. Okay, so here I am just pasting, and I have to rename top n price products. Okay, almost all the logic is same. Only difference is we have to improvise over here. So first, what we have to do, we have to get top n prices. Okay, so how can you get? So rec dot underscore 2 dot to list will give the will convert our input or the iterable which we are trying to process to list. Okay, and from that, for each input record, we have to get the price by passing that. How can we do that on this? Any guesses here? So it is like this, right? So if you go back to this one, and if you say val L equal to list of, copy this one where there are 3 strings, L dot for each println. There are 3 records in this. Now for each record, I need to extract this. Okay, and I want to then sort the data in descending order by price, and then I want to get the top n. Okay, so first thing is, for each input record, I want to get the price. So which API I should use? So the way you should do is hit L dot, type L dot and hit tab if you are using console. And here also you can actually see all the APIs that are available. You can scroll down and you can decide which one you want to use. So can you guys confirm which one we should use in this case? For each input record within the collection, I want to get the product price extracted. Yeah. Can someone from online guess which API we should use? You can also look at these APIs. You can spend some time and look at these APIs and confirm which one we should use. Any guesses? I will give 15 seconds time. You can also, if you have Scala, you can just launch Scala and you can actually say something like this: L equal to list of hello 2.5 world 3.0. So it actually created a collection, and then you can say L dot and hit tab, and you will get the list of APIs that are available. And you just have to go through this. And here, what we are trying to do, we are just trying to extract this one from each record. That's it. It's very easy to simulate using REPL. Any guesses? Okay, so let me do this. So L is a type collection, and the output we are looking is also of type collection, and each element of the collection we have to get the price. So we have to use map, and this map is Scala collection map. It's not Spark map. Okay, because we are trying to use the API on the list. RDD is extension to the list. That's why you will see overlap of some of the functions, and it has some unique APIs also. So we have to use map here, and then for each record that is passed as input, we want to get the price. So what we have to do, rec dot split. Okay, and the price is 4th field, and then we have to typecast it to float. It will give the collection with prices. So this is what we need to do. Okay, so we have to just apply the map function, and this will actually get collection of prices assigned to top and prices. But on top of this thing, I don't need all the prices. I just need top and prices. Okay, so first what I can do now, it is just of type plain collection of float. To sort the data, there are sort by, sort with, and sorted, 3 APIs. So in this case, we can directly use sorted. And if you, okay, sorry, I have to do sorted on this. Sorted. Now you can see data is in ascending order. Okay, if you want to sort the data in descending order, you have to use sort by. Okay, and k implies minus k, and it will sort the data in descending order. Okay, if you don't want to apply any logic and just you want to sort the data in its natural sorting order, then you can use sorted. But in this case, we want the prices, top end prices, uh, uh, based on descending order of the price. Hence, we have to use sort by only in this case. Once you sort by the data, we can use take, and if we just want to get top two, we can say dot take of two. Okay, so if I say dot take of two directly, and if there are, let's say, um, if I say three, or if I say three, and if I want three, you can see that there are some duplicates here. So we cannot directly use take of three like this. Instead, first, after sorting the data, you have to apply the distinct and then take of two or three, whatever it is. Okay, so we have to apply this logic to get top end prices. Okay, so here we have to say take, sorry, first I have to use sort by, I can actually say minus underscore dot distinct dot take of of 3 dot to int. Otherwise, what I will do, I will create a variable here where top n equal to outs of 3 dot to int, because we have to reuse it multiple times, so it's better to specify like this. Okay, so what this will do, it will only get top n prices, and this is how you should program when it comes to Scala. You should not use for loop and all those things. You have to understand different functions that are available, and you have to develop in functional manner. Here, what we are trying to do, from the list, we got the prices, sort the prices in descending order, apply distinct to get only the distinct values, and then use take to fetch whatever number of records you want. Okay, and then what we have to do now, we have to pass each record in the list, look up into this top end products, top end prices, and if the price falls in the category, then only we want to get that, otherwise we want to discard. So here we are trying to process rec dot to underscore dot to again. We have to sort the data, okay, by price, so that we actually display the data also in descending order. After applying the logic up to here by sorting data into descending order, we have to do the lookup into the into this list, and if it falls into that, then we want to consider, otherwise we want to discard. Okay, so here what we have to do, we have to apply filter, because after sorting all our records in descending order by price, so this one will actually sort the all our records within each list in the descending order by price. Once that is done, I just want to filter out which is not part of the top end prices and consider only those which are part of top end prices. Hence, I am using filter. Okay, and then you can say rec dot split comma dot to float dot, and we in this case we have to set top end prices dot contains. Okay. We are checking this whatever. No, we cannot put that side. We have to, because here so contains should have uh, contains is on top of collection API. Okay, so top and prices is collection, and then dot contains is an API in collection to check whether the passed argument is an element in the collection. Okay, in this case, reg dot split is the element, and we are trying to check whether that element is part of the collection, which is top and prices. Hence, we have to use top and prices dot contains, and then pass the element. In this case, element is nothing but price using this logic. Then only those records that are part of that collection will be considered, others will be discarded. Okay, and that's it. Now you will get the top and priced products. Okay, and now let us test this. In this case, again, I have to go to edit configurations. Okay, and I have to copy this one, add a new application, program arguments, program name is top and priced products, and then SMS is the class path of module, and then top and price products. Okay, and then run this. So it is done. The output directory location is same. And if you look into this part, now if you see the 19, even though we pass only 3, it got 5 records because the top priced product is 189.99, second one is 149.99, and then 139.99 there are 3. Okay. Similarly, if you go to the 54, which I have shown you as example earlier, '54, '59. You can see there are so many hundreds, and then 170, and then 169.97. All the top and priced products are written. No, distinct is to get 100, 70, and 69.97. Okay.
100 should be there.
No. First, if you look into the logic, I'm using distinct to get the top end prices, top 3 prices from the products within each category. Okay, we are not actually using distinct while retrieving the records. We are using distinct to get top end prices. If I don't use distinct here, for 59.99, sorry, for category 59, what will happen? All 3 prices will be 100. Only hundreds will come. It will not get top end priced products. That's why, as part of this, we have to use distinct. Okay, is it clear for everyone who is online? Any questions here? Because this is very, very important. From certification perspective, they might not go up to this level, but in general, to write the applications and all, you need to know all these APIs. This example will try to improvise your skills both of Spark as well as Scala, or whatever programming language you are trying to use. Okay, so that being said, now what we have to do, once we complete the development and tested what we are supposed to do, we have to build the jar file, ship it to the cluster, and run it on the cluster. Okay, so idea projects, S&S, DT package. It will generate the jar file. I have to get the credentials. So let me log into the labs here. SCP target. Okay, and then dww at dw01.itversity.com. So whenever you copy remote using SCP, make sure you give the path also after colon. Otherwise, it will create a file with this name, and then it can cause some issues. If you already have a file in the target, you might feel that it is already copied, but that one will be having the older code, and then it will be very tough to troubleshoot sometimes, especially under the pressure. So never ever forget to give the path if you are trying to use SCP. If you are using WinSCP and all, it's fine. You don't make such kind of mistakes. But if you are using WinSCP, if you are using SCP or FTP, make sure you give the path in the target server. In this case, tilde represents the home directory, which is /home/dgadraju on the remote server. So now I am logging in. And if I run ls-ltr, you can see the file here, and you can run the date command to make sure that it is just copied. April 8th, 125, and now it's only 126, so it will just copy it. Okay, now I can do Spark submit. Okay, first parameter should be class, and the class name should be qualified, fully qualified class name, which includes the package name and the class name, which is this one. Okay, and then master yarn, because I want to run it in yarn mode, and I want to run with only one executor in this case because it's a very small program, and I want to run on a unique port, so I'm actually configuring the port number also. Okay, and yeah, that is correct. That's fine. So for configuration, I have to use equal. Someone have asked the question. Let me finish this and then I will respond. Okay, just give me a moment. Equal to 21567, and then we can give the jar file name, which is this one. And the first parameter is the environment which we are trying to run, which is prod in this case. The second parameter is public retail underscore TV products, which is nothing but input path. Output path is this one. And then I want to get top 5 and hit enter. Now it will start running. We can go to the resource manager web console. It is already ran. It should be done by now. Click on history, and this is the program, and this is the DAG. So it ran only in 2 stages. In the first stage, it applied a filter and map, and then it shuffled to group by the key, and then it applied the flat map. And as part of the flat map, we have the function logic which is invoked, which is executed. We have the code which is executed, and then the output is saved as text file. Okay, so and now we should also validate by taking this path to make sure that data is copied there, and then we can say Hadoop fs-cat. And you can get the data. Okay, now you see for 5 there are 7 records, 6 records which fall in the top 5 category: 499.99, 299.99, 209.99, 2 199.99, and 1 179.99. Okay, and here still one thing is still it ran in 2 tasks. Okay, even though I have mentioned number of execute as 1, still it ran in 2 tasks. I don't know why it used 2 tasks. I thought it will use 1 because it's very. I think the number of tasks is also by default 2. Minimum number of tasks. There should be some parameter which can actually override that. But anyway, yeah, number of execute is 1, but it has actually used 2 tasks. But the input is only 1 file. Let me see. Hadoop fs-ls public retail underscore db products and hit enter. There is only 1 file, but still it used 2 tasks. I think its minimum number is 2. Okay, so Jajati is asking, is there any way to deploy and run the jar from IDE itself? I don't think so. I don't think, and you don't do it in any application. You always build the jar file, and then you submit the jar file either by either to WebLogic or WebSphere or cron, whatever is the tool which will be used to execute the jar file. You will be integrating to that. Typically, we don't use IDE to deploy and run on the cluster directly. You take any example, even if you develop a J2E application, you might be able to run the server within the IDE. Okay, but you will not submit your program on the remote server. Okay, not jar, but can I didn't get it.
From IDE itself, he wants to run that Spark server.
That's what you never do that. So even here we have ran it locally. Okay, if you want to run it to the local cluster, you can launch Spark server in the standalone mode, and you can run against that if you want. Okay, but you will not be able to develop on your PC and run it on the lab which is remote to you using your IDE. That is not possible. Not only with respect to the Spark, but also in general, it is not possible. Within your IDE, if you want, you can launch it. For example, if you are developing a J2E application, within the IDE, you can launch a WebLogic server or Tomcat server, or you can integrate with local WebLogic or local Tomcat server, and you can submit to it. But you will never be able to submit to a production cluster or test cluster which is remote to you. The same rule apply here. You can have Spark standalone servers or Yarn configured on your PC, as a client. Your PC should be client to YARN, and then you will be able to run against that cluster which is accessible to your PC directly. In this case, your PC is a Windows PC and the cluster is remote completely. Your PC is not even configured as client and direct client, hence it is not possible. You can do that. As per my knowledge, you can do that. I don't know. I think remote can be done using SSH external. I'm not sure. I'm not sure about SSH external plugin. One way to do it is, if you don't want to log in, you can say SSH, give the username. For that, again, you have to first copy the jar file to the remote server, and then you can actually say like this, dwground.itversity.com. And if you have this Spark submit command, you can actually issue the Spark submit command like this, and it will work. So, for example, let me take this. Okay, probably it might be possible also, but as per my knowledge, I'm not 100% sure on that. Okay. Okay, I think I understood what you were trying to say. Yeah, if you are trying to talk something like this, wherein you from your client itself, you copy the jar file and submit the jar file remotely. Yeah, probably it could be possible. And that is a valid way of doing it. Okay, that is valid way of doing it. And with continuous deployment and continuous integration, that is getting a lot of traction. And I do it even for my labs.itversity.com project. Yes, it probably it could be done. I'm not 100% sure though. Or even if you think about it, right? What I have done, I just ran fcp command to ship the jar file to the remote cluster, and then I log into the remote cluster and run it. If you want, you can automate it. It's not a big deal. You can say you can write a simple script locally, which will run sbt package. It will generate the jar file, and after that, you can run fcp command by enabling the passwordless login between the local PC to the remote server, and then you can actually run ssh command like this. And then you can give whatever command you want to run here. It can include Spark submit. Okay, so you can just write a simple script, sbt package and fcp command with passwordless login and SSH, and you can actually set up passwordless login. So for all these things, if you want to set up passwordless login, you can run something called SSH copy ID. Okay, for that you need to have the public key and private key for SSH, and you can run this command. First time it will prompt you for the password. Okay, here I'm going to labs. Only first time it will prompt you for the password. Now the key is copied. Your public key will be copied, and then you can run this command going forward. It will not prompt you for the password. Okay. Now, what I'm trying to tell you is, if you have Spark submit command like this, you can copy this exit and say, because you have passwordless login enabled now, you can pass that entire thing like this, and it is running. Okay, so there, like this you can do. Okay, so now what I will do is I will give you some time, and you can actually uh, take this code and try to implement as part of the IDE. And also, I will give a use case which you can practice now or later to make sure that you are very comfortable with this. Okay, so I am going to discuss. Okay, and here you can choose big data, and here you can choose workshop exercises. There are multiple exercises, especially to cover this group by API quite extensively. One is Scala and Spark political analysis for the state of UP. Okay, so this was not to perform the analysis, but just to explore the APIs and write some complex programs. So if you know the history, in 2014 general elections, which is Lok Sabha elections, BJP, BSP, Congress, and SP contested separately. So it's a four-way contest. And in recent elections, it was three-way contest: BJP, BSP, SP with Congress. Okay. Now I just want to see. So I have the data in this location, the Lok Sabha 2014 results. And if you look into this URL, it gives the state name, constituency, candidate name, and the several other details about his gender, the category, the age, party name, party symbol, uh, how many votes are received in general in ballot, how many are received in postal. Okay, so let me edit this file. Hello. Who is this? Just 1 minute. Okay. Guys online, just a minute. I will be back. Okay. Yes. Yeah, you can go. Okay, so this is the data, and here you can see that for each constituency we have multiple records. Okay, and from this data set, what you have to do is okay, from this data set, what we have to do is we have to use those multiple records for each constituency, and we have to get the number of records received by BJP, number of records received by BSP, and we have to add the number of records got by SP and Congress, and then if this is greater than BJP or BSP, whoever was winner last time, that means it will change the equation. So we need to get the details about if the alliance was there in 2014 just by the number of votes. How many votes, how many seats BJP would have got, and how many seats alliance would have got. So that's the main intention of this exercise, and it is a very good exercise. It's not very complicated, but it will test your skills, Scala and Spark skills, quite a bit. And data set is very small; it's not very big. Okay, that is one exercise which you can do offline. And if you have any questions at any point in time, you can let me know while developing it. Okay, and actually I also provide the solution. You can review the solution also after you develop the program. And another exercise is the same logic what we have developed against products. Here I am doing it on New York Stock Exchange data. So we have the data available as part of the cluster under root fs-ls public nyhc. And we have these 21 files, approximately 9 million records. And in this, if you just You can see the first one is stock ticker, second one is the date, and then four um, price attributes. The first one is open price. This fourth one is close price. This one is high price for the day. This one is low price for the day. And then this is volume. So from this data, by getting volume, I just want to add uh, at month level and see the number of and see the details about the stocks um, based upon the top end parameter which is passed. Okay, if I want to get top 5 products, top 5 stocks based upon the volume traded for each stock, it should give 5 stocks. If I give 3, it should give 3. Okay, you can use this one also to develop the similar program. And you can come up with many such use cases, simple use cases. Just improvise on your Scala and Spark skills, going through our 6-table retail data model. And if you have any data sets also, let me know. I will public data sets and I will create exercises on those things as well. So let me give the URLs here. This is one. And the other one is this one. These two are the exercises. Okay. And that being said, now I will give 10 to 15 minutes of time and you can use this code. I think I have in the gist also. Let me open the gist. Yeah. So I have for okay, let me mute everyone. Just yeah, actually everyone is muted. I don't know. Okay, so you can actually see the answer for the top and volumes here. Again, the functionality here is almost same. Only thing is you have to uh, just tweak a little bit as per our requirement. Okay, this one is actually and let me see the other one also. I think I should have the products one also. If I don't have, I will create gist for that. Hmm? It is not working at all. Database Google github.com top 10 products. So let me search real quick. Yeah, here, top end products dot Scala. So in this case, I just created it as a separate function and I have invoked that. Okay, so you can use this as reference. Okay, you can use this as reference. Try to create a new program as part of IntelliJ and then test it in IntelliJ. And then you can stick to the cluster and run it on the cluster also. So we'll take 5 minutes, 5 to 10 minutes break, and then I will give 15 minutes time for you to do these things. So approximately we will resume at 11:45. You can take break also in this somewhere 5 minutes somewhere, but I will be back in 5-10 minutes. I will be available from 11:35 itself. Um, you can take break anytime. If you want to take 20 minutes break, that is also fine. You can take care of these excerpts later also. And then we'll continue on data frames. Okay, and group by key is very, very important. And even though there's a lot of emphasis on Spark APIs when it comes to certifications, in real world case, real world scenario, your programming skills are more important than API skills. API skills are also very important. On top of it, your programming skills will actually have a lot more weightage than Spark APIs. Okay, so we'll resume at 11:45. We'll start with data frames. It will take 3-4 hours to cover everything related to data frames, and also we have accumulators and broadcast variables. We will cover that also, and then we'll got into data frames. So at 11:45, we will start with accumulators and broadcast variables. Once we cover those things, then we will get into data frames, and then towards the end of the session in the afternoon, we will cover Spark streaming.
Number of tasks. Number of tasks. Two. But you are searching actually. But this number of executors on also, if you still launch executors.
Yeah, I think
You were checking that.
No, I'm not checking. By default, it uses 2, I guess. Minimum number of tasks will be 2, I guess.
Amen.
So we have 4 more minutes and we'll get started. Okay, so some people have raised on issues related to Flume. I'm just having a look at that while you are working on the program. If you have any questions, let me know. Okay, so let us get started. Instead of covering broadcast variables and accumulators, I will cover data frames first, and then I will come back to the broadcast variables. Okay, and there is a reason why I'm doing that, and you will understand later why I'm actually covering broadcast variables after covering data frames. So, what is data frames? Typically, right, when you have the data, when you try to process, there will be structure to most of the data. Even if you think about Twitter, where people say processing unstructured data, they give example of Twitter. But still, the metadata of Twitter tweet is structured. It gives the information about who tweeted it, who retweeted it, and all those things. So still, there is some structure to the metadata of Twitter. The tweet itself, yes, it's a simple 144 character statement, and people can type whatever they want, and we have to run machine learning algorithms to process that data is unstructured. But typically, for the most of the other cases, for example, if you want to get the number of tweets by or number of retweets for a tweet, etc., you can still process it as structured data. Traditionally, you create the table if you want to define the structure and process using the table in the form of SQL. But with the programming language like Python and R, they introduced a concept called data frames. With data frames, what you can do is, even though there is no predefined structure to the data, you can define the structure on the fly, and you can issue queries or any other API, to process the data in developer-friendly fashion. Instead of writing very complex programs, you can use SQL skills or some other skills which you already possess to process the structured data. So that's where data frames comes into picture. Instead of having a pre-created table, we can actually define the structure on the fly. So let me give a example real quick, and then you will understand what data frames is rather than talking on theory. So here I'm launching Spark Shell. Okay, when the Spark Shell is launched, you will get two variables implicitly. One is SC, which is of a Spark context, and the other one is SQL context. And the type of SQL context is by default Hive context. But data frames is a lot more generic than Hive context. You will understand that in a moment. You see, Spark context is available as SC, and SQL context is available as SQL context. And if you run SQL context, it will show you the type of it. It is of type Hive context. Okay. On top of Hive context, there is a more generic or Spark native SQL context, So typically to use the data frames, we use Spark native context. And the way you can use Spark native context is, let's name it as native. And before that, let me import org.apache.spark.sql context. Okay, and then I'm creating native and context, a native context, and I'm saying new SQL context, and we have to pass the current Spark context to it. Only then we will be able to run the programs. Okay. Now you have created a context, and typically to define structure to the data, at least on the fly or as part of your program, you should have some structure. Means you have to define a class or case class or object, whatever it is. So in this case, we will be creating case class. Okay, and I will be creating case class for orders, and the fields are order ID, int, order date, string, order, owner ID, int, order status, string. Okay. Now we have created the case class. If you are in the Scala, you can actually do Java P, and you can see bunch of methods that are available, which we have seen quite a few times earlier. Now we have to start processing the input data, and we have to apply this case class onto it. Okay, we have done that earlier also. If you look at the earlier program which we have developed for daily revenue, we have created case class for orders, we have created case class for order items, and then we have applied the map function, and we have actually apply orders, which will result in RDD of type orders. Okay, so this is what we have done earlier. So I'm just copying this one. And here I'm giving, let me do this. Let me create val input path equal to public retail underscore db, and then let us run this. And if you see, orders is of type RDD, and each element is of type orders. Okay. Now, if you want to define, already we have created a case class, and we have mapped it to the case class by applying the map function while processing the data. Okay, so now RDD is of type orders. Each element is of type orders. You can also validate by saying orders dot first, and it will give the toString function of our case class. You can see it is of type orders, and it has given the elements comma separated. That is the toString functionality of the case class, which will be provided to you implicitly. Okay, now to define to query the data. So there are multiple ways to query the data from here. Either you can so if you want to filter the data, you can process it as typical RDD itself by applying the transformations which we have covered so far, like filter, map, aggregate by key, reduce by key, etc. Instead, if you want to use a lot more friendlier language such as SQL to process this data, what you can do is, first you have to create a data frame using 2df, and to access 2df function and all those things, we have to import native context dot implicits dot underscore. So everything under implicits will be imported, and then only the 2df and register temp table, those will be available to you. Now you can say orders dot 2df. Now what will happen? It actually converted that RDD into a data frame. And to convert into a data frame, first you need to define the structure. Without defining the structure, if you try to convert the data frame, it will not help you much. Okay. Now, what you can do is, once you convert to data frame, you can actually say register temp table, and you can give whatever name you want. In this case, let us give the name of O to it. Now, O can be used as a table as part of your select query. You can write queries on top of this. Okay. Now, if we want to run query to get completed and closed orders, what you can do is you can say n context.sql and then select star from O limit 10. Okay. And again, the output will be of type data frame. I don't have closed bracket. And the data type is again data frame. And if you want to actually get the results, you can say for each println. Okay, how to use collect, I guess. Yeah, show also will work, but collect also will work. Okay, so data frame is created here when I say orders.2df. Once you create the data frame, either you can register it as temp table and run it like this, and also there is a concept of data frame operations. You can use those data frame operations also like this. If you are from Java background, right? When you develop Hibernate programs, Hibernate applications, you have something called Hibernate query language. Okay, so instead of writing the verbose SQL type of query, you can use certain APIs within the Hibernate to filter the data and all those things. So data frame operations is similar to that. Okay, now instead of writing query like this after registering the temp table on data frame, if I want to use operations, so first I am creating df orders.toDF. So I'm assigning it to a variable. Now orders.df is data frame. If you want to, there are set of operations on data frame which you can directly use instead of registering it as temp table and run the query. One is to get the schema, you can say print schema, and it will give the schema. You can run show command, and it will retrieve 20 records in well formatted way. And then if you want to filter the data, you can say orders.df.filter. Okay, and here we are actually trying to filter on order status.
Which set of data frame operations we get from programming? What is the limitation? What all we can use from the data frame?
I didn't get you.
Like after creating a data frame, what are the operations you can perform? Is there a limited set of operations?
Yeah, most of the operations are available. You can do filter, group by aggregations. You can do joins, sorting. Everything can be done. But it's up to you which one you want to use. Whether you want to use SQL or you want to use data frame operations. Typically, people are familiar with SQL. Once they define data frame, they try to use that. Probably they might have created this for their testing purpose. I don't know. Okay, so here we can say orders df and for equal we have to give 3 equals. So this filter is different from RDD filter. Okay, this filter is data frame filter, and it takes the column name like this, data frame name and the column name. Let me see. Let me run it. If it is correct, we will continue. Otherwise, we will try to fix it. Okay, and then we can say complete. Okay, and then you can run show. You can see you got all the completed orders. So Vicky, I missed few questions. So let me take these questions before going further. And one more thing is, please send it to everyone rather than send it to privately to me. Please send it to everyone. So Prem is asking, I read somewhere online that data frame are faster than RDD transformation. I'm not sure about it. I don't think so, but there is something called data sets. Data sets are faster than data frames. Uh, I haven't explored data sets yet, but I know few features where data sets tend to be faster than data frames, but I don't want to get into those details. Data sets is out of scope from the syllabus. And Vicky have asked, can we get a existing Hive table schema? Yes, you can get existing Hive table schema, and then you can actually either use data frame operations, or you can actually write it in the query. We will see Hive a little bit later. For now, let us first understand the data frame operations, and we will try to use Hive also. Okay, and you can store data in Parquet format. I don't know what you are trying to say, Prem. If you can elaborate a little bit on that. Anyway, don't worry about Parquet format at this time. We will see that later. Parquet format I'm not going to cover quite extensively, but we'll see that later. For now, let's focus on the data frame operations. Okay, so you have filter. Now you see filter is, this is how you filter the data. We have to give the data frame name and we have to give the column name like this. Okay, and if you want to apply or condition, end condition, and all those things, you need to know the syntax and you have to use those things. Okay, now let us try or. Now you got both complete and closed orders. If you want to use the end, you can use the end. Okay, you can. You have to understand all the possible combinations. So this is the simplest filter. Once you and now if you want to aggregate, okay, let's say I want to get count by status. What I can do, orders ds is the database name, data frame name, and then it has an API called group by. Okay, and as part of the group by, we have to give the column name on which we want to group by. In this case, I want to group by order status. Okay, and then you have aggregate function where you can, I think you can say count of, let's say, orders df order ID. Okay, so here we are first trying to group by order status, and then we are actually aggregating by using ag function, and in that we have some average, min, max, etc. In this case, we are just trying to get the number of records, so we can use count. And unless you import that implicits, this will not work. This count, sum, all those functions will not work. So import the n context or the default Spark SQL context dot implicits dot underscore. You have to import everything under that. Okay, and then you can say show. Hit enter. Now it is running the program, and you can see the count of orders need status. Okay, so this is aggregating, and if you want to join the data, for that we need to have two data sets. So here I am trying to create case class for order items. Now I want to first apply the case class on the input data, and then we have to convert into data frame, and then we have to join. Okay, orders underscore orders df is the data frame orders for orders, and here I am trying to create order items df equal to sc dot text file. Our input path plus order items dot map rec implies, actually I can copy it from here. So we can copy till this point because we want all the fields. Okay, and then 2df, and you got the data frame. Sorry, it. You can say df dot show to validate that you are getting the data. You can use print schema to print the schema. Okay. Now if I want to join and then aggregate, uh, and then if you want to get the order item subtotal for each day on completed and closed orders. Now I'm trying to combine all the things. First, I will show you how to join. Then we will actually do the filter group by aggregation along with the join to get to the desired result. Okay, so val, let me use Sublime Text to develop so that we can modify or fix it if we want. So the first thing what we want to do is we want to filter orders df dot filter, and we want to get completed and closed orders, right? So this is the logic which we want to implement first. Okay. And then we want to join. And here we want to join orders df with order items df, comma. It takes two parameters because we have to, with respect to RDD join, both the data sets are in key value pairs, and it joins automatically based on key. Here they are not key value pairs; they are data frames. Hence, we have to tell the join condition. Okay. So in this case, we want to join by saying by using orders df order id, and then order items df order item order id. Okay, that is the join condition. So once we filter and join the data, now we have to consider aggregating based on the date. Okay, so here I have to say group by, and we have to use orders df order date. Once it is grouped by order date, we have to aggregate based on order items df order item subtotal. Okay, this will actually aggregate the data, and then we have to sort the data, right? So I think sort is the function, and in this case I want to sort it based on order date. Okay, so this is similar to this query: select order date comma sum of order item subtotal from orders join order items on order id equal to order item order id, where order status in complete group by order date, order by order date. Okay, so this query can be written like this in the form of data frame operations. Now let us run this and give it a name to it. Well, results equal to, and then results dot print schema. It gets only order ID and sum of order item subtotal, because that's what we are trying to get. Okay, there is a select also. If you want to select first and do certain things, you can do that also. There is a select. So for example, from orders, if I just want to select order ID and order date for whatever reason, I can say dot select. Okay, and then order ID, comma, order date. I think this is the this is how you can get order ID and order date. If you want to use select as part of means if you want to fetch only certain fields on the data frame, you can use select also. Okay, so in this case, based upon this functionality, it only gets order date and the order item subtotal. Okay, so here you can say results dot show, which will run the complete query and get the data. You can see the 20 records in the ascending order by date. Okay, and you can see the revenue for each day. And if you want to get all the records, you can just say collect for each println. Okay, so you can get the complete data. So when you actually try to run using data frames, I don't think you will be using data frames like this, except for the certification. In general, we will try to use SQL. Even in terms of certification, HDPCD Spark requires skills on data frame operations, but with the CCA, they explicitly mentioned Spark SQL with Metastore, which means high. So when it comes to Metastore, you don't need to worry too much about these operations. Even with HDPCD Spark, once you have the data frame, you can register the temp table and you can write typical queries. Okay, so this is the example for this query in the data frame syntax. So how you want, if it is immutable and if you have to write using data frame operations, first you should visualize in traditional query, and then you can, or you should understand the flow. That is more important. So in this case, we have to, if there is any filtering on the raw data, first thing you need to do is filtering, and then we join the data using join operation, and then we have to group by, because our use case says get the aggregated order item subtotal as revenue for each date. That's why we grouped by order date. Then we have used aggregate function to sum to add the item subtotal to get the revenue per day, and then we try to sort the data saying sort. I'm not sure how you can actually sort in descending order. It might take another parameter which says whether you want to sort in ascending or descending order. Okay, so this is how you can write. So again, to use data frame operations, first thing you need to do is, even if you don't have Hive table, if you want to perform either data frame operations or queries on top of it by registering it as temp table, in both the cases, the common steps are to create the case classes, apply the case class on the data, and create RDD of that case class type, so that you define the structure on the data and apply the structure on the data. And then you can make the choice between data frame operations or SQL syntax on the data. Okay, so here I will give 10-15 minutes time. You can log into the cluster and try to create the case classes. You should have this program from earlier. Okay, you can create case classes from this directly, and also you can use this functionality, and then you can try various options of data frame operations. Okay, make sure you are comfortable. At least you should know what is data frame operations, and you should be able to write even at least the simple queries. And case classes and collections are the most important aspect from Scala. Collections and the operations which you can perform on the collections. You should build as much knowledge as possible on collection APIs. Yeah. You can try data frames on local also. You don't need to log in onto the cluster. You can, as long as you have local copy of these retail DB data, you can actually try data frames locally also. So let us get started. So any questions on data frame operations? We will see more when we actually dig into Hive context. Okay, and also I will try to cover JDBC, how to use JDBC to connect to the remote database and use data frames on top of it. Okay, so now we have three variables. One is SC, which is nothing but Spark context, which will control the web service which will be running this session to facilitate us to submit jobs or submit queries, etc. And then we have SQL context, which is created when we started the Spark shell, which is of type Hive context. And then we have N context, which is of type native SQL context. Okay. Now, as Vicky have asked, if I want to get the structure from the existing Hive table, what I can do is I can use SQL context, which is already using Hive context, and then SQL. In this case, I have a database called WLabs DG, and there are tables. I can say select star from WLabs DG dot orders, DG dot orders. Okay, now it will connect to Hive and get the data. And what is the output? Output type, it is of type data frame. Once it is of type data frame, you can do data frame operations also. Or if you want to use query, you can use query. So on this data, let me create a data frame here. Now you can say O dot show. It got the 20 records. O dot select order ID, comma, order date. Okay, it actually now we have to again say show. It got order ID and order date. Now, if I want to filter, either I can use where condition in the query itself, or I can use any data frame API. Filter, if you want to do aggregations, you can do group by and then apply aggregate functions, etc. Okay, so that is how you can actually fetch data from Hive and apply data frame operations on top of it, or you can run queries by using Hive context.sql function. If you want to run queries on top of data frames which are created based on case classes, in that scenario, you have to register as temp table and then you can run the query. So either you can convert a case class into temp table and run a query, or you can convert case class into a data frame and you can apply data frame operations. Similarly, you can convert your Hive table into a data frame and apply data frame operations, or while fetching from the Hive itself, you can query. And internally, it uses the same engine. So the complexity to process the data on these different top layer technologies will be similar. Okay, everything will be running in the Spark context. It will be running in the distributed mode. Execution wise, you will not see much of a difference. Okay, and now if you want to connect to a remote database through JDBC, and then if you want to fetch the data and apply data frames, you can do that also. So what are the uses of data frames? So here in this case, data frames is primarily that middle layer, on top of which you can query the data in the form of SQL. You can query the data in any APIs which are developer friendly. Okay, and also one more advantage is, even though you do not have the table pre-created, still you can define the structure on the fly and you can query the data. Sometimes what will happen, you will get data from third-party application along with the metadata. You might have to apply the metadata on the data, and instead of writing programming language APIs, if we can convert it into data frame and register it as temp table, you can use SQL type of queries. Or if you are very comfortable with the data frame operations themselves, you can use data frame operations. So it will reduce the complexity of the development, and also it does not require to have a predefined structure on your data. You can define the structure on the fly and still use developer-friendly APIs or interfaces such as SQL to process the data. That is the advantage of data frame operations. Okay, so in this case, let's forget about tables. Okay, let's say we only have comma separated data. We have to write a program like this. Okay, think about Java. If you have to write a similar programming in Java, you have to write a very big program. With two tables in Scala, you don't see much of a difference from the development perspective, whether you write it in SQL or whether you write it in data frame, sorry, SQL or RDD operations. But if you have to join 5 tables, let's say you want to get revenue for each department for each day, you have to join orders, order items, products, categories, and departments. And for each table, you have to you have to identify the key and value by applying the math functions. You have to join them separately, and the program will become very verbose and very complicated. If you use data frames, you can just define the structure, and then you can just join as you perform the join in select query. If you register all the 5 tables as temp tables, you can just run the query joining all the 5 tables. You don't need to worry about identifying or defining the key value pairs and then apply the join operation separately and then aggregate finally. Okay, so let me show you an example here. Now you have let us start. First, I created the case classes. Okay, and this is the amount of code which we have written to process as RDD, just to join 2 tables. Okay, you need to be aware of the math function, you need to be aware of reduce by key function, you need to be aware of sort by key. Okay, here let us don't save it to the revenue per day equal to okay. And then if you look into the history, okay, it is not giving all the lines. Let me do 200 lines. Yeah. So it started from here. First, we have created case class orders, second case class order items, then map function, which includes the filter, and then we got order ID and order date from orders, and because those are the 2 fields which we require to join, and then we apply this logic in order items. Okay, and then finally we wrote this logic. Okay, but if we use if you use data frame operations, sorry, not data frame operations. Let's say we created case classes for both orders and order items. We just wrote this logic to apply the filter, join, group by, aggregate, etc. This is a lot more smaller set amount of code, which compared to RDD operations. So your development timeline can be smaller, and also people are more comfortable with SQL than all these APIs. Okay, and if you translate it into SQL, you just write 3 lines of code like this. once you apply the case classes using math function, after that you just have to write this. It includes the filter, it includes the join, it includes the what is that? No, filter, join, and after join we also do reduce by key, and it includes the sort by sorting the data also. Okay, so this is much more easier to express compared to using Scala based, compared to using RDD based APIs. When you compare with Scala, Python along with the SQL, you don't feel much of a difference when you are dealing with fewer tables. But when you join many tables, you will definitely see the difference. If you have to write this in Java, you will admire using data frames. Even with the data frame operations, the complexity will reduce significantly. Okay, and also if you already have Hive tables, so data frames is generic structure. It supports Hive, it supports JDBC, it supports case classes to define the structure on the data. And you can write whatever is comfortable to you at the top layer to interact with the data, like data frame operations or SQL, and you can do the processing or you can finish the development of your application much faster. From performance perspective, you have to so when it comes to using data frames, you will not have as much control as you can have on RDD. When you try to use RDD, you can actually specify number of tasks at most of the transformation level. You can coalesce, you can repartition. There is a lot more flexibility for you. But when it comes to data frames, you are at the mercy of whatever Spark thinks is better for you. You might be able to override certain things if you get into more details about APIs and how to tweak those APIs. But in general, when it comes to performance, using RDD operations will give you a little bit more flexibility and control compared to using data frames. It is same as any programming language versus SQL. SQL, you are messy at the underlying database, the way it works internally. Whereas when you program explicitly, you have more control, and if you are a very good programmer, you might get much better performance than SQL in some cases. Okay, so now let us talk about Hive context. So let us continue talking about Hive context. I will cover few more important aspects, and then I will get into the JDBC. Okay, so SQL context is of type Hive context. Okay, so using SQL context dot SQL command, you can run any valid Hive query or Hive command. So to switch to the database, what you will do in Hive, you will say use and give the database name. In my case, the database name is WLabsBG. Okay. Now, even if I do not prefix my table names with the database name, it will directly use this one. Okay. And now, if I run query, okay, it is in multiple lines. So that's why it is failing. Let me change it to single line. You can also do the line break, but for now, I will convert it into the single line. Okay, and then I am saying SQL context dot SQL. Okay, and output is of type data frame, and it has generated a system column also here. And if you want to see the results, you can say show, and it will give the results. Okay, So it is as simple as that. If you have Hive, access to Hive, and if you know the table names, if you know the database name, you can directly run like this. Same query, we can also use it with native context, because we have created case classes, we have applied, we have registered as temp tables with the same names and with same columns. Hence, the same query will work on this also. Okay, because I have overridden in the middle, it is causing some problem. Let me do this real quick. And also we'll see the difference with respect to performance and all. That I'm quitting from this, and I will run cleanly now to compare the performance of the. At least we will try to compare the DAG between using Hive context and Spark native context, as well as we will also try to run normal way also using RDD, and then we will see the difference about the performance. Okay, so first I will create input path variable. Come on. Okay, input path is public retail underscore DB. Okay, then I am creating case classes for orders and orders. So first I am writing it as RDD operation. Okay, so I'm reading the data to orders and order items. I'm creating two variables, orders and order items. Okay, and then I'm running this, and instead of saving it as file, I'm just saying collect for each println. This is the first one using RDD operations. Now, if you go to Resource Manager web interface, okay, and this is the session which is running right now. Let us see the DAG. So this program have run in two jobs. The second job is just to collect the data and print it. It is not doing much. The first job actually did a lot of work. It actually uh, 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 it actually resolved into 4 stages, and in the first stage it got order items data. In the second stage it got orders data. In the third stage both are joined, and in the fourth stage data is aggregated and sorted by key. Okay, so this is the DAG for for this job using RDD operations. Now, instead of using RDD operations, let us start exploring the data frame and use data frame operations. Okay, so already we have case classes for orders and order items, so we can leverage those things. Okay, and here, first thing I have to do is I have to create the native context equal to arg.apache.spark.sql context. sc, and I have to create object of it. So I have to use new, and then I can say import n context dot implicits dot underscore. You have to import this one. Then only you will be able to use data frames effectively. Once that is done, okay, our case class names are orders and order items. We have to apply the map function, and we have to convert it into data frame. So I'm using this one. I'm creating data frame by name orders df equal to 2df. Similarly, where order items df equal to, here I'm only copying till this one, 2df. Now these two are data frames. Okay, and let us run these two things. Now using these two data frames, let us run this code, which I have tested earlier. So this is the running the query using data frame operations. Let me paste this and then collect for each println, so that the program is run. Collect is an action. Only after seeing the connection that it will run. Okay. And now if you see, if you go to these jobs, this is the invocation, and you can see the DAG for it. Okay. Now you see internally it is using some explicit APIs, sorry, implicit APIs, which are not exposed to you, like tungsten exchange and all those things. Okay, and also you see some of the things actually happened in parallel. Okay, so this is how DAG look like using data frame, and this is the feature of data frame. This tungsten exchange, all these things, the complexity is hidden from us. If you want to explore, you can explore, and you can try to understand a little bit more further. It uses typical, so this map is primarily from while applying the case class. So first we have applied case classes, then applied the filter function as part of the data frame operations. Even then you can see filter here. So it works in similar manner up to the point where it actually starts shuffling the data. Okay, so this is the DAG using data frame operations. Now let us try to write it in SQL. Let me take this call. Hello. Yes. Take one line in the middle of the class. I will call back. Okay, so this is the data using data frame operations. Now let us try to write SQL by creating the data frame tables using register temp table. So here I am saying orders df dot register temp table. I'm giving the name as orders, and then order items df register temp table order items. Okay, now if we run the query, this one in native context, n context dot SQL collect for each println and hit enter. Now the query is running. If you see, it is using 200 tasks. I will explain the reason, and also I will explain how to override that one. And if you go to the job, if you go to here and click on jobs, this is the one, and you can see the DAG is almost same. It does not change. Now let us run in Hive context. Okay, so I'm using a SQL context, which is of type Hive context, which is implicitly created when we launch the Spark shell. SQL context.sql, the query, and then collect for each println and hit enter. Okay, I have to say SQL context.sql use wlabs dg. And now it is running. Okay, now if you go back to here and click on jobs, so these two are the jobs. This one is the one which got failed, I guess. Okay, and then you can click on this, and this is a little bit different. When it comes to Hive context, the execution plan is, or DAG is a little bit different. Okay, and if you see, you have something called broadcast hash join. So that's why I have deferred the broadcast variables. Okay, so this uses a different approach while joining the data using certain important parameters in Hive and important feature in Spark, which is called as broadcast variables. Okay, so which one is better? You have to look into the several metrics, and you have to determine which one is better. Okay, and one of the things which you need to keep in mind is whenever we run this query, it is using 200 tasks to process the data, which is a overkill for very small data, and which can be underkill for if you are trying to process terabytes of data. So you should know how to change those things. So the way you can change is you can run SQL context or native context. You can use either of them, and then you can say set conf, and you have to set this one spark.sql.shuffle.partitions, and you have to give the value as string, even though it's integer. You have to put it in double quotes, otherwise it will not accept. Let us give it as 4 instead of 2, just to test it. And now if you run the query, it will only use 4 tasks. I think it completed very fast, because with 200 it has to create so many JVMs and come out of it. But you can go to the job history server or job related web interface, and you can see now it only used 8 tasks compared to 400 tasks as part of the last run. Okay, so this is how you can change the number of tasks which can be used to process the data. SQL context dot SQL. So if SQL context is Hive, you can pass any Hive query, valid Hive query or valid Hive command here. For example, if you want to get a parameter value from the Hive context, you can say set map reduce dot job dot reduces, and then show. You can get the value. The value is -1. If you want to overwrite, you can just say equal to 1. Yeah, this will have some impact. Not all properties, but whatever properties Spark uses internally, you will see the difference. Now you can see the value is overridden to 1. Similarly, if you want to switch the database, you can say use, and you can use the database of your choice. In this case, let us use the same thing, wlabs dg. Okay, and now you will be running queries against tables in this if you do not prefix your table names with the database name. And then if you want to run insert command or load command, if you are familiar with load command in Hive, this is not Hive course, I'm not going into details, but if you are already familiar with load commands and insert commands in Hive, you can say SQL context dot SQL. Let's say I want to create a table out of the output, which we are running here. Okay, so let us define it here. Create table as, create table order revenue as select star from. This is the query. You can copy, paste this one. And the table will be created with the data. If you already have the table and if you have to insert, you just have to run insert into table name, select. You can apply whatever query you want to insert into the table. And to validate, you can again run SQL context.sql, select star from order revenue limit 10 or so. You can see the data. Okay, like that you can run any Hive query. You can load data using load command. You can perform almost all the steps using SQL context.sql, as long as SQL context is Hive context. Okay, you can validate that by just typing SQL context. It will give the data type of it, which is Hive context. Okay, so now let us see the JDBC also. Before getting into the JDBC, if you have any questions with the material covered so far, this is very, very important. If you require to improve your skills in Hive for the preparation, you can go to my playlist, which is CCS Spark and Hadoop Developer. And here I have covered Hive up to a certain extent. If you already know Hive, it will use it. It will come handy as reference. If you want to learn SQL itself, I will be conducting a workshop, but already there is another playlist which says Big Data Workshop Live Training 2017 January, and in that you have a lot more content with respect to Hive. Okay, so in this playlist, CCS Spark and Hadoop Developer, it's only 6-hour content, whereas in this it starts at 16 and ends at 28. So it's almost like 13 hours content. So if you want to little bit, if you want to explore Hive a little bit more in depth, you can actually go through this playlist. Okay, the name is Big Data Workshop Live Training 2017 January. I will try to create the blocks on these things so that you don't need to struggle too much about these things. But for now, I'm just giving you these things to you as references. CCS Spark and Hadoop Developer also have Hive content, but it assumes that you already know a bit of SQL, and it will take it from there. Okay. Now let us get to the JDBC. Okay, when it comes to using JDBC, while launching Spark Shell itself, you have to use jars and you have to specify the JDBC jar of the database which you are trying to connect. Okay, so in this case, there is a jar file under user share Java MySQL connector java.jar and hit enter. So this jar file will be available as part of this session. Hence, you will be able to use JDBC. Means you can connect to the remote database using JDBC, and you can actually create data frame and you can do whatever you want. So now let us go to this Spark programming guide and go to data frames, datasets, and SQL. And here let me search for JDBC to other databases. Click on this. So either you can say Spark class path and give the class path like this, and then you can start Spark Shell, or you can also, I guess you can also do use jars to pass the jar file Let us see. If it failed, then we'll go back to this thing. And then this SQL context needs to be native context. You cannot use Spark context. Somewhere they might have imported, or probably it might work with anything. Anyway, let's try. Let's try with SQL context itself. SQL context dot read dot format, and here we are using JDBC. Okay, and JDBC, when you try to use JDBC to connect to the source database, you have to pass options such as URL to your database, DB table, etc., so that it can connect. And these things have to be passed as a map. The reason why they are expecting as map is that the parameters might be different for each time. So the number of parameters might be different for each time. That's why you have to build the map, and then you have to pass those things. So it takes URL, it takes DB table, it takes driver. You can also say partition column, lower bound, upper bound, number of partitions, fetch child, etc. Okay, and I need to figure out how to pass the password. Let me check. This does not have. Okay, so let me, I think I have the code in my GitHub account. So let me go here. Okay, so earlier it used to be like this: SQL context.load is the command, and you have to pass the map function like this. But now it is changed. Okay, so this is how you can connect. First, we will create the URL. Okay, let me remove this. I'm creating the URL like this, and in this, the host name is nn01.itversity.com. Port number is same, 3306. Username is retail_dba, and password is itversity. And then you do SQL context dot. Is there load? There is a load command. Let me try this example itself. Load JDBC map URL and then DB table. Let's say departments. Okay. Then collect. It should not take such a long time, unless there is a typo in the nn01.itversity.com. It is correct. Okay, so it is working. Load is also working, but I think this one is deprecated. Load is deprecated. Instead of load, you should actually run SQL context dot, as per the documentation as of 1.6.2. JDBC to other databases. You can use SQL context.read.format. read.format JDBC dot options map URL DB table departments. Okay, and it is creating again data frame. So if I actually assign it to a variable, val df equal to and then if I say df dot show, okay, I think it will still not work. Df dot. So these are the parameters that are these are the functions that are available. It has a format each instance of JDBC, JSON, mode, options. Df dot collect. Okay, I have to use load. This is the reason. Now it will be data frame. Now I can say df dot show and get the data. Okay. So what we are trying to do, we are actually querying the table and creating the querying the table in the remote database and querying the data frame out of it. Now either you can actually register the temp table and write SQL queries on top of it, or you can actually perform data frame operations also. Okay, and let us see what are other options. Yeah, you can see here register temp table is there. You can actually register it as another table and you can do whatever you want. And one more thing you need to keep in mind is this does not give a lot of flexibility to as in scoop. It will not give a lot of flexibility to limit the column names and all those things. But you can work around few things. For example, you can create a view and you can pass the view name as part of the DB table. Okay, so as long as something can be expressed with simple name, you can actually use a table or view to fetch the data. When it comes to limiting what you want to fetch the data from remote database using Spark SQL or data frames over JDBC, the options are very minimal. You can only specify partition column, lower bound, upper bound, num partitions is I think how many threads it should use. Okay, so these are the things which you might try to use. Lower bound and upper bound are just used to decide the partition stride. I think with respect to partition column, you can specify what is the lower bound and upper bound, and then it might use some where condition internally. I haven't explored those things much. Okay, but if you want to capture delta using Spark JDBC, what you can do is first you can create a view in the remote database, which will fetch you the delta, and then pass the view name as this parameter. Okay, it's all Scala, right? You can also use the Scala and connect to the remote database using JDBC, and you can issue whatever queries you want on the database side. So you can somehow integrate the complete flow using Scala itself. Okay, that is about data frames working with JDBC. So after the core APIs, the most important one is data frames and Spark SQL. Any questions here? So we have covered data frame operations. We have covered registering those data frames into temp tables and run queries against it. We have covered converting high queries into the data frame, and we have covered converting data from a remote database into a data frame. And also we have seen the DAG of each type of queries um, um, to understand the differences when it comes to execution of those queries. We saw one major difference when it comes to data frames using Hive. When we try to run the query using Hive context, it used something called broadcast hash join compared to a typical join with respect to data frame operations, and we will understand those things when we cover um, broadcast variables and accumulators later. Okay, that concludes the session about Spark SQL and data frames. I'm not going to cover datasets because datasets is more matured when it comes to 2.x. So when I actually create a workshop in future on Spark 2.x, I will try to cover datasets and all these things. I also haven't done any R&D on datasets. So Prem, you have asked the question before also. Yesterday I attended one interview in Spark. In that they asked tungsten. It was totally nightmare for me. Okay, tungsten is. I also don't know what tungsten means, but we see this term when we actually run data frames or Spark SQL. My question is regarding DAG. When action is performed, only then you see DAG diagram. That is correct. Until you, but there should be a way. Let us see. Okay. Let me do one thing. Val sc.text file. Sorry. RDD equal to sc.text file. Public retail underscore db products. Okay, and then val rdd map equal to rdd.map I'm just trying to run simple map function to see if there is any API on this which will give the DAG related details. Now, if I see here, aggregate as instance of coalesce, compute, distinct filter. No, it does not give DAG related details here. Yeah, unless I think you run action, you will not be able to get the DAG related details. At least from the API perspective, which are exposed, it is not showing any API which is obvious to us. Probably there should be a way, but I'm not sure at this time. Okay. Yeah, there is nothing. Okay. Okay. Good to know. I will. Let me confirm. Spark get. Oh, nice to know. I think we spoke few days back, if I'm not wrong. I will explore that. I will explore about how to get the details about DAG even before we execute. Okay. That being said, let us take the lunch break for 1 hour, 1 hour, 5 minutes. We'll be back by 2:15, 2:20 ish, and I will resume the session. So I will be concluding the YouTube live session, but I will be opening another session for Hangout. So you can come back and join. I think you already have the link. Let me paste it. Sure, Prem, we can talk tomorrow, okay? Today I will be there. I will be part of the session till 6. So I might not be able to talk to you today, but I will try to catch up with you tomorrow. Okay, so let me give the playlist. It is part of this playlist. Sorry, let me give the URL. It is part of this playlist itself. If you go to that, you will get the link for the session. We will start it in approximately 1 hour. Okay. That being said, thank you very much. And if you like this video, please click on the like button. If you want to provide the feedback, once the streaming is done, you can post your feedback in the comment section. And if you have to share with our friends, just click on share and share with our friends. And as you guys, if this is the first time you are coming to my session, if you need environment to practice, go to labs.itversity.com and you can practice from here by subscribing to one of these plans. And if you have any questions, start writing under discuss.itversity.com. We will try to answer your questions, whether you sign up for the lab or not. That being said, thank you. Bye. And I will leave the WebEx session like this, but we'll resume in 1 hour. Bye.